You push a quick bug fix to production on a Friday afternoon. You drag and drop the files manually onto your servers. 10 minutes later, your entire application crashes. Users are getting 500 errors, and you are scrambling to figure out which file broke the system. Why? Because you relied on manual human deployment, and humans make mistakes. Let me show you what actually happens when you push code to AWS using a proper CI/CD pipeline and how it automates your deployments safely.
Think about it like this. A CI/CD pipeline is an automated factory assembly line for your code. Continuous integration is the quality control checker. It automatically builds and tests your code every single time you push an update. Continuous delivery is the delivery truck. It automatically takes that tested code and safely releases it to your infrastructure without you lifting a finger.
The automated journey happens in 3 steps: source, build, and deploy. It kicks off with the source stage. You commit your code and push it to a repository, like GitHub or AWS CodeCommit. The moment your code hits that repository, AWS CodePipeline detects the change and triggers the entire workflow automatically.
CodePipeline immediately hands the code over to the build stage. This is powered by AWS CodeBuild. CodeBuild spins up a temporary pre-configured compute environment in the background. It pulls down your raw source code and looks inside for a very specific file to tell it what to do.
This is where people mess up. They configure CodeBuild, but the build instantly fails. Why? Because they put their build instructions in a subfolder. For AWS CodeBuild to work, you absolutely must have a file named buildspec.yml located at the exact root of your source code repository. If it is anywhere else, CodeBuild panics and crashes. CodeBuild reads that buildspec.yml file, installs your dependencies, runs your automated unit tests, and compiles the final software. But how does the compiled software actually get to the deployment servers?
Through artifacts. When CodeBuild finishes, it packages your compiled application into a file called an artifact. It does not hand this directly to the deployment server. Instead, it securely uploads that artifact into an Amazon S3 bucket. Think about that for a second. Your pipeline stages are completely decoupled. CodePipeline acts as the invisible coordinator, taking the compiled artifact from the S3 bucket and passing it down the line to the next stage.
Now here's where this gets interesting. You don't always want code to go straight to production just because it passed an automated test. You need a human checkpoint. In CodePipeline, you can easily add a manual approval stage. When the pipeline reaches this stage, it completely pauses execution. It triggers an AWS CloudWatch event, which fires an Amazon SNS notification directly to your QA manager's email or Slack channel. The code sits frozen. Only when a manager clicks approve does CodePipeline grab the artifact from Amazon S3 and move it to the final deploy stage. In the deploy stage, a service like AWS CodeDeploy takes over. Just like CodeBuild needed a build spec file, CodeDeploy looks for an appspec.yml file to understand exactly how to safely install your application onto your Amazon EC2 instances or Lambda functions.
Now imagine this. The deployment goes through, but the new code contains a hidden memory leak that starts crashing your EC2 servers one by one. If you deployed manually, your business would be down until you figured out how to revert the changes. But because you are using CodeDeploy, you are safe. CodeDeploy supports automatic rollbacks. If it detects that your deployment failed, or if you configure it to watch an AWS CloudWatch alarm that suddenly triggers because your CPU spiked to 100%, CodeDeploy will automatically halt the deployment and instantly roll your servers back to the last known stable version of your application. Your users experience zero downtime, and your application self-heals.
Let's lock this down. 3 rapid takeaways for the DVA-C02 exam and production. 1. CodePipeline automates the release process, moving code sequentially through source, build, and deploy stages using Amazon S3 to store and pass artifacts. 2. AWS CodeBuild requires a buildspec.yml file placed strictly at the root of your repository to execute build commands and run your automated tests. 3. You enforce production safety by adding manual approval stages that notify teams via Amazon SNS, and by configuring CodeDeploy to trigger automatic rollbacks if CloudWatch alarms go off. One final warning. Never skip the testing phase in your buildspec.yml file just to make your pipeline run faster. A CI/CD pipeline that doesn't run automated tests isn't a safety net. It is just a highly efficient machine for deploying broken code into production. So, how confident are you in what your pipeline is deploying today?